A battery made from table salt, a piece of copper wire, and a glass of water can generate electricity using materials that cost almost nothing. It sounds like something from a school experiment, but the science behind it is very real. This isn't new. The same electrochemical principle has been studied for over a century. It's the basic idea behind how batteries work. Two different metals, an electrolyte, and a path for electrons to flow. In simple terms, when you place two different metals, like copper and zinc, into salt water, a chemical reaction begins. The salt water acts as an electrolyte, allowing ions to move freely. This movement creates a flow of electrons from one metal to the other. That flow is electricity. You can measure it, you can test it, and under the right conditions, you can even power small low-energy devices like an LED. Historically, similar setups were used in early communication systems and experiments. Simple electrochemical cells helped scientists understand electricity long before modern batteries existed. Even today, variations of saltwater-based batteries are being researched as safer, more environmentally friendly alternatives to lithium-based systems. But here's the important part. This isn't a replacement for modern power systems. A basic saltwater battery produces very low voltage and limited current. It's useful for learning, small experiments, or emergency low-power situations, but cannot run your home, charge your phone efficiently, or replace commercial batteries at scale. Modern batteries are designed for high energy density, stability, and long-term use. They rely on advanced materials and engineering that simple setups just can't match. Still, there's something powerful about this idea. With just a few everyday materials, you can create a working electrical system from scratch. No factory, no complex tools, just chemistry doing what it's always done. And in situations where resources are limited, understanding these basic principles can actually matter, because sometimes the most important knowledge isn't about replacing the system. It's about knowing how things work when the system isn't there.